So, literal equations. When we're talking about literal equations, like I told you guys before, we're talking about equations that are pretty much either one or two numbers and mostly variables, or no numbers whatsoever. Okay, so we'll start off with something real simple. I have f minus h is equal to m. And I'm saying, hey, I want you to go ahead and solve for f. Okay, this is called a literal equation. Okay, you can still solve for it. You're just not going to get a number for your answer. You're going to get an expression. Okay, you're going to get an expression instead of a numerical value. So we're solving for f. That means that f needs to be 100% isolated with nothing else happening to it. Okay, it just needs to now say f equals. So that means right now, anything that's on the same side as the side that f is on needs to be removed by doing inverse operations to it. So currently, we just see that f has a minus h. So what would be the inverse? Plus h. So we're going to add h to both sides of the equation. Now, do I know what m plus h is going to equal? No. So again, my answer is just an expression. F is equal to m plus h. That's it. That's my answer. You are just rewriting the equation so that a different variable is what you're set equal to. Okay, let's take that exact same equation. F minus h is equal to m, but this time I want to go ahead and I want to solve for h. Okay, when I solved for f, all I had to do was add h to both sides. Now I want to solve for h. That means I want h completely isolated. So that means I need to remove the f first. How am I going to remove the f? Subtract f. Okay, so I'm going to subtract f. Even though this is a subtraction sign here, that subtraction sign does not belong to the f. Okay, so we're going to subtract f from both sides. But we're not left with h by itself. We're still left with a negative h is equal to m minus f. Okay, so now what do I need to do to get h by itself? Divide by negative 1. Good, because this is a negative 1 that's as a coefficient to the h. So we're going to divide by negative 1. Well, how do I know which number to divide by? You don't get to pick. You divide the entire thing. The entire expression is getting divided by negative 1. Okay, so if this entire expression is being divided by negative 1, then here are several different ways that you could write that answer. You could write it as m minus f in parentheses over negative 1. Okay, that's what h would be equal to. Or you could write it as negative m plus f, right? Because m divided by negative 1 would become a negative m. Negative f divided by negative 1 would become a positive f. Okay? Or you could rewrite the order here. You could write it as f minus m. Either one of these would be acceptable answers. Okay? But you have to know it in all formats. You would have to know it in all formats. You are still following the same process. So like I told some of you guys when you were doing some small group with me, I said before when we're solving equations, it's kind of like what? Who remembers? Solving an equation is just like you lost something, right? What do you do when you lose something? You retrace your steps, okay? So the steps in math, when we work out problems in math, the steps are your order of operations, where you always do parentheses, then exponents, then multiplication or division, whichever comes first in the problem. And then the last thing you always do is addition or subtraction, whichever came first in the problem. But when something is lost, You start at the end. You retrace your steps backwards. So that means you always get rid of anything that's added or subtracted first. Then you move towards multiplication and division. Then you move towards exponents. You get rid of exponents. Then you move towards getting rid of anything in parentheses. Okay? So you are retracing your steps when you are solving. That's the important thing to remember. Okay, let me give you guys another one. Yeah. Okay, so because it's a minus h, remember if it doesn't have a coefficient, it always has an invisible coefficient, right? The 1. And h is not by itself if it's got a minus sign. H has to be by itself when it's positive. Okay? All right, let's take a look at another. This is a simple one. We have g times f is equal to h. And I want to go ahead, I want to solve for g. So what are we going to do to get g isolated? I want to get g all by itself. So Brooklyn, you're giving me the stink face. So I'm going to call on you. Brooklyn, what currently is happening between g and f? What operation is it when they're side by side? Multiplication. So what would be the inverse? Division. So if I want g by itself, what am I going to divide by to get g by itself? F. That's it. So you're just going to divide by f on this side, but that means you have to divide by f on the other. Okay, so those are now going to be gone, and g is isolated. G is equal to h over f. Okay, let's take a look at one more. Yeah. Okay, let's say that we have, we'll do 3x minus y is equal to m. 3x minus y is equal to m. Okay, we are going to go ahead and solve for x. We're going to solve for x. So what do we need to do first if we're solving for x? We're going to add y. Good. So we're going to add y to both sides. That's going to give us 3x is now equal to m plus y. What do we do now? Divide by 3. And what are we dividing by 3? The whole thing. So we're taking this whole thing and we are dividing it by 3. Okay, so x is going to be equal to m plus y in parentheses divided by 3. Okay. Now, one other thing that I want to make sure you guys know. So go ahead. If you've got room on your little page still, that's great. I wrote too big, so I don't have room. So if you don't have room, you can go ahead and flip it on over to the next. But on here, one other thing that I want to make sure you guys understand. Because I had one kid ask, well, you said that when you work through your order of operations, you know, you do your addition and subtraction first, and then you do multiplication and division, and then you do exponents. How do you do exponents? Does anybody know what the inverse operation to an exponent would be? So what I mean, like, if I have an inverse of x squared, does anybody know what the inverse would be? Not, well, no, because division's inverse is multiplication. Exponent is not just multiplication, it's repetitive multiplication. What do you think, Asa? A square root. Very good. A square root. But not every single exponent is a 2. So what if I said it's going to be x to the 4th? what would be the inverse operation for an exponent of 4? Not a square root. It is a fourth root. You have more than just a square root. Square root, so let me let you guys know. Did you know a square root is actually an exponent? A square root is an exponent. The exponent is 1 over 2. So your square root, or any of your roots, are just fractioned exponents. So what it means is when you're doing an inverse, if you're taking an exponent, the inverse would be the reciprocal to that exponent. Well, the reciprocal of 4 is 1 over 4. 1 over 4 is a fourth root. Okay, a fourth root. So every single exponent has an inverse, which is its reciprocal or its valued root. So when you have a x cubed, you have a cubed root. Okay? Okay, you have a cubed root, like 27. The cubed root of 27 is 3, because 3 times 3 times 3 is 27. Okay? All of these have inverse operations. This is going to be very important when we get into Pythagorean theorem. Okay? Pythagorean theorem is a geometric concept. Yeah, well, you're going to do geometry later. Yeah. The exponent, the power. Because this is an invisible root. So it's automatically, a square root is automatically a 2 for the root. Okay? That's why they're called squared roots. You don't have to put the 2 there. All right. So, turn your paper on over to your warm-up for today. You've got 4 literal equations that you're going to be working through. 4 literal equations. This is lesson number 5. We're getting into translation. But before we started, I wanted to get you into those literal equations. Take a couple of minutes and do problems 1 through 4 very quickly. Okay, problem number 1. We've got y is equal to mx. We're solving in terms of x. That means that we are dividing both sides by what? M. So we're dividing both sides by m, so we're going to have x is now equal to y divided by m. Okay, problem number 2. Problem number 2, we have r is equal to x plus y plus z, and we're solving in terms of y. We want y isolated. So in order to get y by itself, we are going to do what? Subtract. Okay, we're going to subtract x from both sides. We're also going to subtract z from both sides. So we're subtracting an x and then subtracting a z. So that means y is going to be equal to r minus x minus z.
I am cooking.
Good, what are we eating?
Cookies.
Woo, I love cookies. All right. Oh, by the way, I absolutely love some of y'all's answers to the way ground. I loved them. Asa, yours was boring. Luke's was much better.
I was going to put it with your head on it.
Oh.
I was going to put the yearbook better.
No. All right. Problem 3. We've got h is equal to BA minus r, and we want B isolated. What are we going to do first?
Divide by
Addition. There you go. We're going to add r to both sides. So now we have BA is equal to h plus r. What's our last step? Divide it by a. Divide everything by a. Okay, so that means b is going to be equal to h plus r in parentheses and then divided by a. Okay.
I got it right.
All right. Last one. What are we doing?
Okay, so we're gonna
Divide, good.
Both sides. And you would get X over P equals X.
Wow, y'all like all shouting over each other. Okay, K is going to be equal to X over P. All right. Shh. Let's go quickly. We have translation. Shh. So we're taking. I don't like having to be too loud. That's how I lose my voice. I don't like that. Jack? Yeah? Well, yeah, no, he does, because I don't like people getting up and walking around. What?
Does the order matter?
The order matters that you solve, yes. Order does matter. Okay? Yes. Fantastic. I'm still going to go over it. All right. Problem number 1. So what we're going to be doing here, in these situations, you are just translating. You aren't solving. You aren't solving any of these questions today. All we are doing is writing out what the equation would be as a setup to these situations, these contextual problems. That's all we're focusing on, is identifying what your constant and your coefficient, what's your variable, what is it set equal to. So it's kind of similar to what we did with expressions last unit, where you translated an expression from word problem to the actual algebraic expression, but this time it's being set equal to a value. So you have to identify what your context is trying to equate to. So here, it costs $12 to attend a golf clinic with a local pro. Buckets of golf balls for practice during the clinic cost $3 each. You can spend $30 for the entire clinic. Okay? We want to write the equation. So the first thing we want to do is identify what are we setting the entire equation equal to. 30, right? We are setting it equal to 30 because that's the amount that we can spend. Okay, we can spend $30. That's what we are going to be set equal to here. So when I set up my equation, I'm going to put that it's equal to 30. So these other values are going to represent parts to my expression. So when I'm identifying it here, first thing I see is the variable that they're wanting me to use. They want me to use the variable b. B is going to be my variable. Okay, so now we need to know what are we doing to that. B is going to represent the number of the buckets of golf balls that we can purchase. So let's read through the rest of this concept. It costs $12 to attend the golf clinic. How many times are we paying that? Once. One time. So remember, we talked about that before, that if you are paying a one-time fee, a one-time purchase, or it's a starting point, okay, this is a one-time cost in this situation, that's going to be our constant. That's the amount of money that we're first doing. We are first showing up, we are paying $12 to be able to get into the clinic. So that's the first thing that we're purchasing, right? That represents part of our $30. Now we're going to continue purchasing buckets of golf balls. Okay, so that's where this part comes in, 3 each. Remember we said that the key words per, each, and every represent a coefficient. So write that down. Per, each, and every is going to represent your coefficient. Remember, a coefficient is what you get multiplied to your variable. Okay, a coefficient is what you're multiplying to your variable. So are we adding that price or subtracting that price? Adding, right? We're trying to figure out how much money we're spending total. So we are adding that to the cost of what we're spending, 3, and then our variable b. So there's our equation. Again, you're not solving anything. Now, for those of you who want additional practice on solving, because these are all just 2-step equations that we're writing here, or 1-step equations, some of them. But if you want additional practice, then here off to the corner, when you solve it correctly, b is going to be equal to 6. So if you want to go through later on and practice solving, by all means you can do that. If you get b is equal to 6, you've done it correctly. Go ahead and flip it to the next page. All right. Let's take a look here. Number 2. Jessica wants to save money so she can buy tickets to a concert. The tickets cost $405, and she's able to save $45 each week as a dog walker. Write the equation to represent W weeks that takes to solve or to save up the money. Okay, so what are we setting this equal to? That's the first thing we're going to figure out. What are we setting it equal to? Chloe? 405, right? That's how much money she needs. She needs $405. So we're setting it equal to 405. Does she have any money yet? No. Nowhere in here does it say she already has this amount of money. It does say that she's going to save $45 each week. And right, we already know weeks is going to be our variable. So that 45 each week, that represents our coefficient, 45, and our variable, W. There's our equation. That's it. Now again, if you wanted to know what it equals once you've solved it, you would get 9 weeks. I'm just going to put that in the corner for you for those who want practice.
9 weeks worth.
Okay. Number 3. Paulo has $145 in his savings account, and he earns $36 a week mowing lawns. If he saves all of his earnings, after how many weeks will he have $433 saved? What are we setting it equal to? 433, right? 433 is what we're setting it equal to. Okay, so now we have a couple of other values here. Paulo has $145. That is his starting amount. He already has this, so he is starting off with $145. Now he's going to continue to save $36 a week. That means we're going to continue adding. Now I had one student who pointed out, they said, well, there's no per, each, or every. But let me ask you, instead of saying 36 a week, could I say 36 per? Can I say 36 each? Can I say 36 every? Yeah. You could replace the word a or with per, each, and every. So that a or that is a per, each, or every kind of word. Okay? That's a coefficient word. So there's our weeks. So it's 36 W. Okay, and again, in this case, W would be equal to 8. After 8 weeks, he would have 433 saved. Okay, what I want you guys to go ahead and do is problems 4 through 8. I don't want you doing 9 or 10 yet. Just do 4 through 8 real quickly. All right, so for problem 4, we're trying to find the cost of the shirt. So we are going to have the equation 3 times whatever variable you chose, 3 times x plus 54.99 is equal to 140.99. If you did 54.99 plus 3x, that's fine. It's the same. Okay, I just wanted to make sure you guys understood that the addition between, those two terms are very much interchangeable. Okay, problem number 5, same thing. It's $35 plus 50 cents per message, and that's equal to $52 for the total cost. Okay, that's old-fashioned ways of how they used to charge us. For problem number 6, $612 for equipment plus the $25 per uniform, or cost of uniforms, is equal to $912. All right, number 7, you should have gotten $75 for the charge for them to come out, plus $25 per hour, so 75 plus 25 each is equal to 200. And then problem number 8, we've got 12 plus 2t is equal to 62. Again, whatever variable you put is perfectly fine, okay, as long as you have the similar concept. Now, the reason I didn't want you doing number 9 and number 10 is because these were the kinds of questions that were messed up the most on the Wayground. It's questions like these. Okay, so we have the length of a rectangle is 11 inches more than the width. The perimeter of the rectangle is 82 inches. We want the width of the rectangle. So how to be able to find the width of the rectangle. So what we have here, they're giving us the perimeter. This is what we're going to be setting our equation equal to. So I'm going to go ahead and put equals 82 because I know how to find perimeter. Who remembers? Perimeter means that you're doing what? Adding all the sides, right? You're going to add all the sides together. Now, if we're talking about a rectangle, how many sides do we have? 4. We have 4 sides to a rectangle. And we know that when we're taking a look at a rectangle, we've got our length that is the same on the top as it is on the bottom, and we've got our width that's the same on the 2 sides, right? So length and width are not necessarily equal to each other, but they are equal to their opposite sides, okay? So in this situation, we are being told that the length is 11 inches more than the width. That means if I create an equation here, a literal equation, length L, which I don't know what it equals, but I do know that it is 11 more than the width. So it is 11 more than W. What does more than mean? Adding, right? So it means we're taking the width and we are adding 11. So here, where I see my rectangle, where I've got those lengths measurements, instead of having the length there, I would then replace it with this. W plus 11 and W plus 11. And on the other side, I would just have W's. Now I can go ahead and create my equation. Remember, perimeter is equal to adding all the sides together. So that means I'm going to add up all of my variables first. So I have W plus W plus W plus W. What is that going to equal? 4W, right? We have 4W. And then we've got our constants. We've got 11 plus 11, which is going to equal 22. So plus 22. So there's my equation to solving for the width. That if I do 4 times W plus 22, it's equal to 82. Okay, here's another one. This time they're actually giving me what expression represents the length and what expression represents the width. So I can fill those in. I can say, okay, my length is 3x plus 4, which means it's 3x plus 4 on this side as well. My width is a half x, so it's a half x on the other side as well. And I know that I'm setting the whole perimeter equal to 43. So I'm going to add all 4 sides together. So I'm going to add my coefficient terms first. So 3x plus half of an x plus 3x plus half an x. That's going to equal 7x. Then I've got a positive 4 and a positive 4. That's going to equal a positive 8. So there is my equation. Okay? All right. Get logged in. You're going to go to quizzes. You need 1 tab only. 1 tab only because you are limited to 1 tab. And the quizzes has time limit. So each question has a time limit. So if you go past the time limit, it marks it wrong. Are you solving anything today?
Yes.
No, you are not solving any of these. The only things that you're doing is rewriting literal equations, which there's 3 of those, and the rest are translations. Huh? There's no work to show because you're not solving anything.